Hello friends, today I am going to talk about some important properties of expectation of real valued random variable. So I would start from where I had left in my last presentation, that is for any real valued random variable x. Let us look at mod x. Then mod x is also a random variable on the same space, but it is a non-negative valued random variable, and there is an interesting relation between the expectation of mod x and expectation of x. So we will first look at that. Now I have told you that mod of x is what? X plus x minus. So it is the positive part of x plus the negative part of x. This is something we have discussed. If you have not seen my that presentation, or I will suggest that you please revisit that. And let us recall what was x plus. X plus was maximum of x and 0, and what was x minus, that is maximum of minus x and 0. So you could easily verify why this is true. And now x plus and x minus are non-negative valued random variables. So I have expressed mod x as the sum of two non-negative valued random variables. And now by properties of expectation that we know so far, for properties of expectation for non-negative valued random variables, so expectation of sum is sum of expectation, therefore we get the first equation. Now let us recall the definition of expectation of x for any real valued random variable. So we had defined it as the difference of the two expectations, where x plus and x minus are the positive and the negative parts of x, and the expectation of x is defined if and only if one of them is finite. Now, so henceforth, unless otherwise stated, we will always assume that one of them is at least finite. Otherwise, it makes no sense to talk about expectation for real valued random variables. So now, so this is something we now from henceforth we will assume that we are talking about only those random variables for which either one of them is finite. Now, for such random variables, this relation, there is a relation that mod of expectation of x is less than equal to expectation of mod x. Now, if you remember basic Riemann integral, there is a similar relation. Integral of a function, mod of an integral is less than equal to integral of the mode. So in mode of integral a to b fx dx is less than equal to a to b integral mode of fx dx. If you recall, so this is a relation of the same type. So why is that so? This follows from the above two equations, that if you see that when, let us assume that both of them are finite. So expectation of x plus and expectation of x minus are finite. So this is the difference of two non-negative numbers, and this is the sum of the same two non-negative numbers. So obviously expectation of x cannot be more than expectation of mod x. And if you look at minus of expectation of x, then it will become expectation of x minus minus expectation of x plus. So in that case also it is the difference of two non-negative numbers, and the expectation of mod x is the sum of the same. So it explains that expectation of x and minus of expectation of x both are less than equal to expectation of mod x, hence we get this inequality. Now when expectation of mod x is equal to 0, then we simply revisit the earlier property that we know, that mod x is a non-negative valued random variable. So what does expectation of a non-negative valued random variable 0 equal to implies? It implies that probability that mod x equal to 0 is 1. Now mod x equal to 0 is same as saying x equal to 0. Now next property is expectation of minus x is equal to minus of expectation of x. Now there is no analogy of this for the this is a property for which there is no analogy for expectation of non-negative valued random variables, right? Because if x is non-negative values, minus x is negative value. So that was not even covered in my earlier topics. So how do I look at this? So let us look at what is so this is a new random variable. So how would its expectation be defined? If we go by the definition, So then it will be expectation of minus x plus minus expectation of minus x minus. Now if you this is the main point really for you to see that minus of x plus, this is really what? This is equal to maximum of minus x 0, right? Why so? Because whatever you are writing here, whether minus x, y or z, this plus means maximum of that random variable and 0. But this, if you recall, then this is exactly the definition of x minus, and in the same vein, minus of x minus would be x plus. So you see what will be this expectation of minus x? It will be expectation of minus x plus. So that is expectation of x minus. So it becomes expectation of x minus minus expectation of x plus. So it is really the negative of expectation of x. So that is a important but simple but important relation. Now next is that if I take a into x, expectation of a into x, that is a into expectation of x, that is for any real number, but it is enough to prove it for a positive. Why is that so? Because of this previous property. Because if a is negative, then minus of a is positive, so you can write minus of a into minus of x. So you and now you know that minus of x is minus will come out, and so if you could prove that for positive a and minus a is positive, then that minus a will also come out. So it will be minus of ax, so that will be ax. So therefore it is enough to prove it for a positive. And again we go by that logic that what will be ax plus. So what will be the definition of a expectation of ax? It will be equal to what? It will be equal to expectation of ax plus. Right, we are just imitating that, we are just applying the definition as it is. Expectation of ax plus, sorry, my typing skills are limited. Expectation of ax minus. So this is what it is, right? And now you have to apply this condition that really what is ax plus? It is a into x plus. Now what would be, now my question is, what would be expectation of a into x plus? Where a is positive. So x plus is a non-negative real number and a is positive. Then by properties of non-negative real number, this will be a into expectation of x plus. And similarly for ax minus. So therefore you would get ax. Okay. Now coming to the last property, that is very important. Of course, all the properties till now are important, that if x and y are two L1 random variables. By the way, what do I mean by L1 random variable? Probably I should write here that if so if a and b are both finite, then we say x is integrable or integrable or L1 or L1 random variable, or x has finite mean. So these are all different ways of saying the same thing. When both of these are finite, then we say x is integrable or L1, or it acts as a finite mean. Why? Because then basically expectation of x is the difference of these two numbers, these two positive numbers. Now it may be both positive, it may be positive or negative. That is another story. So when both of these are finite, I think I have discussed that in the last class. When both of these are finite, and then expectation of mod x is also finite, expectation of x is also finite. And so we are talking, when you let us take x and y to be such L1 random variables or random variables with finite mean, then so is x plus y. That means I am saying that then x plus y also has a finite mean, and in that case expectation of x plus y is expectation of x plus expectation of y. So again, how do I prove that? Again, by definition. So if x plus y has to have a finite mean, then what has to happen? Then expectation of x plus y plus, maybe I should make it bold. This expectation of x plus y plus and expectation of x plus y minus, these two expectations have to be finite. And now x plus y, now it is, I leave it as an exercise for you to verify that what is x plus y plus, how is it related with x plus y plus. How is it related with these two? What should I be putting here? Inequality, inequality, less than equal to, greater than equal to what? So that is something I am giving as a question mark. So for that, again you will have to look at what is x plus y plus. It is equal to maximum of x plus y and 0. Now you think if both x and y are positive, then that will be exactly equal to x plus y, which will be equal to x plus y plus. Now if it is both are negative, then this plus will be 0. Now that will be then x plus is also 0, y plus is also 0. You will get an equality. However, if one is positive, suppose x is positive, y is negative, then what happens? Then it depends upon the sign of x minus y. If x minus y is positive, then you will get x minus y, right? But but then what is the but then that is x when x is positive, then that is equal to x plus, but when y is negative, then y plus is 0, right? So you will get a less than sign. Similarly, if x minus y is negative, then this will be equal to 0, but the x plus and y plus are non-negative, so also you will get a less than equal to sign. So x plus y plus, this will be less than equal to x plus and plus y plus. So therefore, and these are non-negative valued random variable. Again, by properties of non-negative valued random variables, you will have these. So you will have this inequality. And so therefore, if x and y are integrable or L1, that will mean that all these four terms, expectation of x plus, expectation of y plus, expectation of x minus, expectation of y minus, these are finite. So therefore, these are finite, and so their difference is finite. So expectation of x plus y will be finite. So it is L1. Now you see this, that x plus y. So now this is the simple relation. I hope you are able to see why. Because basically we are just using the same fact that any real valued function can be written as the difference of its positive part and negative part. And here I